Hello students, I'm Callie Daniels, and in this video we will take a look at the slope-intercept form of a linear equation. Well, let's first start by considering a line with slope m and y-intercept at the point 0, b. We can find the equation of this line by choosing any other point xy and using the slope formula. So we've got a picture of the scenario, our line with a y-intercept. We know x is 0 for all points on the y-axis, and b is the y value of the y-intercept. Well, all points xy will lie on this line if they maintain the same slope m. Well, the equation of this line comes from use of the slope formula, which is change in y over change in x. So as we subtract our y values, I'm going to choose the order y minus b, change in y, over, now subtract your x values in the same order, x minus 0 in the denominator. Now we're just going to take this formula and we're going to solve for y. Let's start by indicating that x minus 0 in the denominator is simply x. We're going to multiply each side by x to divide that denominator out. So x times m, or m times x, using the commutative property of multiplication, that's equal to y minus b. Remember, we're solving for y, so let's add b to each side. mx plus b is equal to y, and I'm going to switch sides here and write this as y equal mx plus b. Now, y equal mx plus b we call the slope-intercept form of the equation of a line with slope m and y-intercept 0b. If you ever forget this formula, you might be able to walk yourself back through using the slope formula to develop it. Well, in example 1, we're going to identify the slope and y-intercept of the line with each equation. In part A, we have the equation y equal 3x plus 1. Well, the slope is always that coefficient of x. So for this equation, we know that the slope is 3. And this coefficient out here by itself is the y value of the y-intercept. And so for our problem in part A, we can say that the y-intercept is 0, 1. Again, all points on the y-axis have an x value of 0. As we look at part B, you might want to rewrite this equation, y equal negative 1/3 x minus 7/3. Just makes it a little easier to see the slope is negative 1/3, and the y value of the y-intercept is negative 7/3, and so if we want to write that y-intercept as an ordered pair, x equals 0, y equal negative 7/3. Now in part C, we can see that the y value of the y-intercept is 0. There's no coefficient term out here, so we assume it to be 0. The slope is 6. And the coordinates of the y-intercept as an ordered pair are x equals 0, y equals 0. This, in fact, is a line that goes through the origin with a slope of 6. Now, in example 2, we're going to graph the equation of each line using the slope and the y-intercept. So in part A, we've got y equal 2/3 x minus 1. The slope is 2/3. And our y-intercept is 0, negative 1. All right, so we're going to first find that y-intercept, 0, negative 1. And from there, we're just going to count the slope. Rise 2, run 3. So rise 2, and run 3. And the coordinates of this point are 3, 1. And we'll connect the points. I'm just going to do that free-handed here, trying to be really careful. Connect the dots and extend the line. Okay? So when you've got an equation in slope-intercept form, that definitely makes it convenient to graph. In part B, this is not in slope-intercept form, so let's write it in slope-intercept form by solving for y. Start by subtracting 3x, divide each side by 4. That gives y equal negative 3/4 x plus 8/4 or 2. So we can see that the slope is negative 3/4, and I'm going to apply that negative sign to the numerator. You can stick it in either the numerator or denominator, it does not matter. Y-intercept, ordered pair, 0, 2. So start with your y-intercept at 0, 2. And from there, our movement along the y-axis is going to be negative 3, and then on the x, positive 4. So that's a down 3. And then run 4. And the coordinates of this point are 4, negative 1. And connect the points with a straight line. And doing this quickly free-handed, okay? So solve for y, so you can determine the slope and the y-intercept. Makes things easier to graph. Example 3, we're going to write the equation of each line using the slope-intercept form. Now in part A, this is the easiest, okay, of all lines to write the equation for, because we know the y-intercept. This is the y-intercept because it has an x value of 0. Okay, the y value of the y-intercept is 5. The slope is negative 1. So this is ready for direct substitution into our slope-intercept equation. Okay, so b is 5 and m is negative 1. Y equal negative 1 x plus 5. Or let's just write that as y equal negative x plus 5. Okay, our equation in slope-intercept form. Now, part B is hard, okay, or at least more challenging, because the point that we're giving is not the y-intercept. Okay, it's the point negative 2, 1. So this isn't ready for direct substitution. We've got to do a little extra work. Nonetheless, we can still use our formula y equal mx plus b. We know the slope, okay, m is 3. We have an x value that we can substitute. It's negative 2. And we've got a y value that we can substitute, 1. And because we know the value of y, m, and x, we can solve for b. Here we've got 1 is negative 6 plus b. Add 6 to each side to obtain b equals 7. So now we do indeed know, okay, the coordinates of the y-intercept are 0, 7. And now this has become the easy problem and is ready for direct substitution into our slope-intercept form. Okay, we know the slope is 3. And we've determined that b is 7. And so our answer in slope-intercept form, y equal 3x plus 7. All right, so I want you to remember, this is the easy problem when we're given the y-intercept. If we're given a point that is not the y-intercept, we've got to use this formula twice. Okay, first to determine b, and then second to do our straight substitution. And let's see, example 4, and this is our last example for this video. Horizontal and vertical lines, okay, these are the special cases. We're going to graph and write the equation of each line described in part A. The line through -3, 3 with undefined slope. Well, let's locate the point -3, 3. Now, this undefined slope tells us that we're dealing with a vertical line. Okay, you've got to be able to connect those concepts, okay? Vertical line, undefined slope, and because the slope is undefined, there's no way for us to use the formula y equal mx plus b because it requires us to substitute a value for the slope. Okay? We simply have to determine this is a vertical line and therefore its equation is x equal some number, and in this case that would be -3 because every point on this line has an x value of -3. Here's another point on the line, -3, 0. And yet another point on the line, -3, -8. X equal -3 for every point on the line. In part B, we want to graph and write the equation of the line through this same point, -3, 3, with a slope equal to 0. If the slope is equal to 0, that's telling us that this is a horizontal line. Okay, so horizontal line. Okay. Now, every horizontal line looks like y equal some number, okay? And in this case, it will be y equal 3. Now, I would like for you to make this problem that easy, okay? Vertical line, x equal -3, horizontal line, y equal 3, because every point on this horizontal line has a y value of 3, like the point 0, 3, or out here at x equal 8, y equal 3. Now, interestingly enough, for horizontal lines, you can actually use your formula y equal mx plus b because you know the slope is 0. That's y equals 0 times x plus our y value of the y-intercept is 3. 0 times x is 0, and we can actually obtain y equal 3. So you can actually use your formula on part B, not on part A, but go ahead and save yourself some time and simply write your answer for both of these. Okay? In this section, we've talked about the slope-intercept form of the equation of a line. Good luck on these. Remember, show up, work hard, stay positive.